sometimes you have to multiply both equations in order to get a common coefficient that would be able to be eliminated. All right, solve the resulting equation for the other variable, and then you're going to do some substitution. All right, so these are the basic 3 steps. All right, many of you are familiar with this. So let's go on and actually do some examples, because I think the examples is where we'll really see how this works. All right, so in this case, we're going to start out real simple. You're going to see that elimination isn't really substitution isn't an option, because it's not easy to solve for one of the variables. All of them have a coefficient on them, yes? All right. So when we look at our variables now and our coefficients, we can see that these two are identical except for the sign change that occurs. Would you agree? All right. So when that happens, what we do is we add those 2 equations together. We add them together. Because what happens when I add a 2x and a negative 2x? It drops out, and that's the goal. We want one of these variables to drop out. So then we add a 3y and a 5y, and what do we get? 8y. And an 11 plus 13, and we get 24. Solving for y means y is equal to 3. So we know what y is equal to, and now this becomes very similar to what we did yesterday, where we substitute. Now, does it matter where we substitute the y into? Does it matter which equation? It shouldn't, all right? Because in either equation, you'll get the same x, because we're looking for that common point that both lines will intersect at. Does that make sense? All right. So if I take my first equation of 2x plus 3y equals 11, and I substitute in 3, that means I have 2x plus 3 times 3 equals 11. 2x plus 9 equals 11. 2x is equal to 2, so x is equal to 1. So my ordered pair is 1, 3. Does that make sense? So we eliminate right here a variable and solve for the other variable. And then we pick one of these 2 equations, it doesn't matter which one, take this answer, plug it into the y value, and find our other missing variable, which in this case was x. Like if my y's had the same coefficients with sign changes? Absolutely. Of course, you are not guaranteed to have to always eliminate the x. You eliminate the variable where the coefficients are the same except the signs. Okay? Let's do another one. And let's see if we can see this pattern. What is a good equation or variable to eliminate in this case? The 3x and the negative 3x, right? So when we add these together, the whole idea is for those terms to drop out. What am I left with now? 9y equals 18, so y is equal to, all right, there's one of my answers. What do I do now? Hannah? All right, I take this y and I substitute it into either equation. It makes no difference, and I solve for x. So I do a substitution. So if I do 3x plus 4y equals 8, I take this 2 and I substitute it in for that y. Because we know what y is. It is 2. So 3x plus 8 equals 8. 3x equals, so x is equal to, yeah. So the ordered pair is 0, 2. Remember, you have to write your answers as an ordered pair. Let's say I have time and I want to check. What should I do? Okay, so substitute in your values. Does it matter which equation? You should do it. It should work in both equations, yes? Okay. Anna Marie? You're often looking at two things that are independent of each other that you have to put together to be able to find a common value. So you were trying to um, uh, find the least cost for a certain item that you want to sell, and you have these parameters. So you're trying to see, using those parameters, what would be maybe the highest cost of how many items you would have to sell. All right, which variable should I eliminate in this one? X again, right? Positive 1x, negative 1x. You do this problem on your own. Work this problem out. Show your work. So I get the ordered pair 3, 5. Now, I chose to put in the value of y into this first equation. I could have put it in this second one, but why might I not really want to choose that second one? So we want to sometimes make smart choices. What's wrong with the second one that I probably really don't like? Or I see as an opportunity to make a lot of mistakes if I would use that second one. What do you see? Rose? I got lots of negatives in here, and I really kind of want to stay away if I have to do substitution with negatives, because negatives mean I have a propensity to make a sign error. So make smart choices when you're doing this. Either will work, but sometimes one is a better choice than the other. All right. Now, if I had to make a choice, which would I probably want to choose? The y's, right? Now, what's the problem with the y's? They're both positive, so will they drop out if I add them? This is where we change. As long as you multiply every term in that equation by the same value, you're not changing the problem, you're changing the way it looks. So what is a great value that I should multiply through, let's say, the first equation by, so that the sign of this term will change? What should I multiply all the way through by, Jane? Negative 1. This is what I want to see you do. I want you to see negative 1 with brackets. And I need you to remember that you're changing every single sign on that equation. So that means I have negative 5x minus 6y, and this is where we make a mistake. We forget to take that negative to the answer also. It goes all the way. We've got to keep that equation balanced. Now the 7x plus 6y equals 8 stays the same. So now solve. After this, it's exactly the same. Agree? Did you all get x equals 2? Okay. I chose, and when you do your substitution, always go back to one of these original ones up here. Try not to use one of the ones that you changed, just in case you made a funny error. You'll catch yourself, okay? I chose this bottom one. I could have chosen the top one. Doesn't really matter. Lots of places to make errors by signs or multiplication, especially when you're on the phone. Okay. All right. Next one. What am I going to multiply this one by? Which variable do you want to get rid of? X. Does it matter which one I multiply through by negative? But let's make a smart choice. Which one would be a better choice to multiply through by -1 by? So that you're not having to deal with negatives in your answer. Probably the bottom one. Why? Or actually, I would do the top one. Well, I guess it really wouldn't matter because, no, I would do the bottom one. Because if that changes this sign, it also changes this sign, which means I'm not dealing with a negative answer over here. Does that make sense? So if I multiply this one by -1, all right, so that we're on the same page, you finish this problem. And remember, every sign changes on that second one. Are we good? 1, 1. Are we comfortable with this? Some of you guys said that this was no fun. Is this hard? Makes more sense maybe the second time around? Hard last year? All right, let's see. I might want to skip. Okay, I want to skip this one. I want to go to this one. So the next example. Let's move to something harder. All right. Multiplying through by a negative is not going to help me, is it? So we have to choose. Do we want to get rid of the x or do we want to get rid of the y? So I look to see sometimes, look at my signs. Is one of the variables positive and one of the variables negative? Well, in this case, if I chose to get rid of the x's, I have a sign change difference, yes? If I chose to get rid of the y's, I still have a sign change. So it really doesn't matter. If we want to get rid of the x's, I need to have a coefficient of what in front of both of my x's? 3. Just one has to be positive and one has to be negative. Well, this has the positive 3. This one has a negative, but it doesn't have a 3. So what are we going to multiply this entire equation by? Correct. And so the top equation stays the same, and I want to see all this work. And the bottom one becomes -3x plus 3y equals 3. And then it's exactly the same as what you've been doing. You get y is 6. You go back to one of the original equations to figure out what x is. So 3x minus 2y is equal to 3. 3x minus 2 times 6 equals 3. 3x minus 12 equals 3. 3x equals 15. And x is equal to, so the ordered pair is 5, 6. Are we good? All right. What would you like to get rid of? What would be the easier one to get rid of? If I look at the x's, 6 and 4, what's the first multiple they have in common? 12. Not factor, multiple. So 12. That means I would have to multiply both of these, wouldn't I, to get a 12? How about if I look at the y's? What's the first multiple they have in common? Which means I only have to worry about multiplying through by one equation, yes? The signs are different, so we're going to take this one by 2. Okay, finish this problem. At this point, I don't want you dividing. You could if you wanted to simplify it, yeah. Yeah. And that's a good question. So I get negative 10. Agreed? Okay. Then I use one of the originals. I'm going to use that first one because it has less negatives. Bless you. What's 60 minus 25? 45? 35. How'd I do? Math right? Lots of work to show. Show me all the work. All right. Negative 10, negative 7? Negative 10, positive 7. Yeah, look up here. You're going to add 60 to negative 25 and get positive 35. Your 5y is positive, so you get from in the... Okay. All right, what do I multiply by? What am I trying to get rid of? The y's. Okay, which one do I multiply? Top one by? All right, do it. All right. These are up on Moodle. Take a look at them to finish notes, okay? You have another worksheet for homework tonight. Do day 1, please. Do day 1. I'll see you in a couple days.